Today, we're going to completely demystify the complex engineering behind one of the most sophisticated pieces of modern aeronautical technology out there, the MQ-9 Reaper drone. But instead of just staring at dry specs and schematics, we're actually going to experience this tech through a full-on, chronological, simulated mission. From the second those engines roar to life on the tarmac, all the way to the deployment of a highly controversial payload, we're going to break down exactly how this incredible machine operates.
Okay, let's dive right into this. Here is our flight plan for today. First up, launching the Reaper drone. Then, flight controls and fuel. After that, sensors and satellite links. And finally, missiles and precision strikes.
All right, kicking things off with Section 1, launching the Reaper drone, from the tarmac to the sky. Now, before a remote pilot ever even touches a joystick from some air-conditioned room thousands of miles away, this whole life cycle actually starts out on the ground, usually on a sun-scorched runway at a forward airbase. And this brilliantly illustrates the sheer, massive physical scale we're talking about here. Like when you hear the word drone, you probably picture something you can just toss in a backpack, right? No way. The MQ-9 is an absolute behemoth. Get this, the wingspan is an enormous 66 feet wide. That is literally longer than 2 full-size school buses parked end-to-end. Lengthwise, it's 36 feet long, which is roughly 2 SUVs parked bumper to bumper. And standing at 12.5 feet tall, it's taller than a standard basketball hoop. We are talking about a seriously massive aircraft. So how do you even get a 10,000-pound machine like this off the ground? Well, it's a super hands-on physical process. First, you get the ground crew out there sweating in the heat, wearing helmets, fueling it up, running diagnostics, and triple-checking literally every single sensor and circuit. Then, when those engines finally roar to life, remember, there is no pilot sitting in a cockpit. It's the local technician sending this 10,000-pound beast hurtling down the runway. And right after liftoff, a whole series of automated hydraulic actuators seamlessly folds the landing gear neatly into the underbody. It's an absolutely crucial step to cut down on drag so this thing can actually achieve smooth, high-speed flight.
Moving right along to Section 2, flight controls and fuel, handing off and gliding high.
So once it's in the air, there's this critical handoff moment. Controls shifts from that local ground crew to a ground control station that could literally be thousands of miles away in another country. Picture a dimly lit command center where a pilot and co-pilot are sitting in front of glowing screens, hands hovering over controls that honestly look a lot more like a high-end gaming setup than traditional airplane gear. Now, what's really interesting about this is how this massive drone actually turns. The MQ-9 doesn't use your standard ailerons, elevators, or flaps for lift adjustments like a commercial jet does. Instead, it relies on what are called elevons, often just called 11s in pilot speak, located right on the trailing edge of those highly efficient wings. To fly it, the pilot pushes a throttle with their left hand, reaching speeds up to 300 miles per hour, and twists a joystick with their right hand to tilt those 11s. These work in perfect harmony with the drone's unique upside-down V-tail to control both pitch and roll. It makes the whole aircraft surprisingly nimble without needing any bulky flap mechanisms.
Of course, to keep an engineering marvel like this airborne, you're going to need fuel, and a lot of it, 4,000 pounds of it to be exact. That equals about 602 gallons, spread perfectly across 5 internal tanks to carefully balance the weight. This fuel feeds right into the Honeywell engine, which is just a brilliant piece of design. As the drone flies, forward motion forces air right into an intake. A compressor squeezes that air at high pressure, mixes it with the fuel, ignites it, and boom, spins the turbine to power the rear propeller. That staggering 4,000 pounds of fuel isn't just dead weight, it's exactly what gives the Reaper its incredible 1,200 to 1,400 nautical mile range.
But operators don't just rely on raw fuel volume. They use physics. To optimize for those really long duration missions, pilots will climb way up to an altitude of 50,000 feet. The air is super thin up there, so the drone can basically just glide toward its destination, taking a ton of strain off the engine. And here is why this matters. By combining that ultra-high altitude cruising with their optimized fuel load, the MQ-9 can stay in the sky for nearly 2 days. We're talking 27 to 34 hours of continuous flight, depending on how heavy the payload is. They can literally just loiter over a target area all day long before ever needing to return.
All right, Section 3, sensors and satellite links, the eyes and ears of the operation. So, we know how it flies, but how does it actually see anything? Well, to hunt targets or gather intel, it uses this incredible nose-to-tail array of high-tech sensors.
First up, you have the famous Lynx SAR radar. Think of it kind of like a super-powered camera, but instead of using light, it's shooting out radar waves. Those waves bounce off buildings or vehicles and bounce back, giving the drone a perfectly clear picture, even through thick clouds, violent storms, or absolute pitch darkness. Pretty wild, right? Then you've got the infrared sensor, which relies on thermal imaging to spot the heat signatures of people or hidden cars. And lastly, the laser target designator. This literally marks exact pinpoint locations so guided munitions know precisely where to strike. Oh, and all of this is backed up by GPS modules, angle of attack sensors to keep it perfectly stable, and low-light TV cameras.
So the crucial point here is, how does all that heavy, real-time data actually get back to the pilots? That happens through the massive SATCOM dish mounted near the rear of the drone. Since the aircraft is operating far, far beyond the pilot's visual line of sight, this dish beams the data way up to satellites parked out in geostationary orbit, which then bounce it all the way back down to the command center. Now sure, there's a tiny fractional signal delay because of the immense distance the signal travels, but it still allows for insanely precise remote control from the literal other side of the planet. And for any shorter range local communication, the drone just relies on its built-in C-band antennas.
Finally, Section 4, Missiles and Precision Strikes. Deploying the payload.
Now let's move to and see how this builds when an intelligence-gathering mission suddenly shifts into an active strike. This is where the MQ-9's devastating arsenal comes into play. The standard option, housed under those massive wings, is the AGM Hellfire missile. This thing is guided by laser, radar, or GPS, and once it's fired, its solid-fuel rocket motor blasts it toward the target at an unbelievable 950 miles per hour, packing a high-explosive warhead. If they need to bust through tougher targets like reinforced structures and bad weather, pilots might switch to the heavier, gravity-guided GBU-12 or GBU-38 bombs. But honestly, the most fascinating weapon is the AGM-9X, nicknamed the Ninja Missile. Get this, it has absolutely no explosive warhead. Instead, it deploys 6 razor-sharp titanium blades right before impact.
Okay, let's step back inside that ground control station for a second to see how these are actually deployed. The division of labor is super clear here. The pilot flies and the co-pilot hunts. The co-pilot is constantly monitoring this mosaic of live video feeds. Once they spot a target, they literally just use a little thumbstick on their controller to zoom in on a heat signature, which, by the way, might just be a tiny single pixel on their screen. Once they lock onto that target with the laser designator, the physical action of launching a 950-mile-per-hour missile comes down to just a simple squeeze of a trigger button located right below their joystick.
And you know, the specific weapon they choose drastically changes the outcome on the ground, especially in an urban environment. A standard, conventional Hellfire missile creates a massive 50-foot fiery blast radius. So if your target is in a moving car surrounded by civilian traffic, a normal Hellfire would turn the entire street into a fireball, causing really high collateral damage. But the AGM-9X Ninja missile completely changes the game. Functioning basically like a 100-pound flying guillotine, its 18-inch blades create a precise kill zone of just 3 feet, roughly the width of a compact car. It slices right through the target's vehicle with this brutal, almost surgical efficiency. Meaning, innocent bystanders nearby might just hear the eerie thunk of the impact, but they can literally keep driving away completely unharmed.
Which brings us to a profound final thought. The engineering of the MQ-9 Reaper is, without a doubt, absolutely spectacular. From its massive 66-foot wingspan and high-altitude efficiency to its unbelievable ability to strike a moving target with titanium blades from a control room thousands of miles away. It's incredible. But critics keep bringing up one absolutely crucial, lingering question. Can remote-controlled assassination ever truly be considered ethical? Does totally removing the human pilot from the physical battlefield inadvertently lower the threshold for using lethal force? It's a hugely complex issue, there are absolutely no easy answers here, and it's something we really need to deeply ponder as our technology continues to completely outpace tradition. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I will catch you next time.